Good morning. Day before yesterday, I was speaking about this category or this variety of Islamic geometric pattern that is I call non-systematic, and what it means is that the underlying structure, underlying polygonal structure that the pattern is extracted from, those elements, those polygonal elements cannot be rearranged into other combinations to make new patterns. So that the fundamental structure that the pattern is created from is really only specific to the set of patterns created from that structure. And this will become a little more clear if I'm a little bit obtuse. So there's one pattern that has been used by Muslim cultures for many, many centuries that's really very beautiful. It has 12 pointed stars and it has 8 pointed stars, and it repeats on a square module. And it's a classic pattern. You see it again and again. And when we are at the Esrafolu Mosque tomorrow, there's a beautiful example of this very pattern on the mimbar. So this is the same pattern. You can see these are the 12 pointed stars here, 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 and you can see part of it here, and the 8 pointed star in the center. And then surrounding, connecting the 12s and the 8s is this network of 5 pointed stars and these double dart or arrow shapes. So this is a characteristic of this pattern. And so I've got an exercise for you that after I've gone through some slides, I'll be passing out these set of sheets, and I'll be working with you to create this pattern from the radii matrix, which you'll see in a moment. But first, I just want to quickly go through a number of examples of this pattern that are found in the historic record around the world, because there's quite a variety of them. And you'll be seeing, this is the very same pattern with the 5 pointed stars and the dart shape, the 12 pointed stars and the 8 pointed stars right here and here. But this is from the family that's what I call the acute family, as I was talking about a couple days ago. The same underlying structure will make other patterns in the other three families, and I'm going to show some examples of those as well. So you get an idea of the diversity that one underlying structure, which is to say this structure right here, this one tessellation will create a tremendous variety. And even within one family of pattern, this is the acute family, even in the acute family, there's a lot of variety from culture to culture. So there's, I want to emphasize that in Islamic geometric design, there's a tremendous amount of artistic license, a lot of play or ability for the artist to realize the design in many different ways, in many different materials. Each material has its own natural design affinities, things that lend themselves to that material nicely. See, in this case, instead of the line going over and under, it's just outlines of every form. There's no continuous band, it's outlines. So this is one interpretation of this pattern. Whereas at the mosque that we'll see tomorrow, it's not going over and under, but it's continuous lines that are widened. So here's another example of the pattern. By the way, this is a very old pattern. This is the earliest example of this pattern that I'm aware of. So it's late 11th century from Isfahan. And so these non-systematic patterns go right back to the early time of this tradition of art coming into maturity. So now here's another Seljuk example from Ganabad. It's from a little more than 100 years later, you can see the 12-pointed stars. You can see the 8-pointed stars on the edges, right here, right here, right here, here, and here. They're a little bit disguised. You can see the dart shapes that touch point to point. And you can see this matrix of 5-pointed stars, connective stars. So this is an example of a widened line that is going over and under as it moves through the pattern. Here's another beautiful example from here in Turkey. It will also be able to see this this coming week on Friday. And again, widened lines going over and under. In this case, the double darts see how they've changed the angles of the lines here? They've curved them in a little bit. Otherwise, this line would be going straight across right here, straight across right there, and you'd have the double darts. But in this case, the artist, because as I say, there's always the opportunity for artistic license, for developing the pattern in one's own way, instead of having to be rigid to the form. So in this case, the artist wanted to open up a 6-pointed star here. It's a clever idea. So the artist curved this line in, curved this line in, curved this line in, curved this line in, and opened up this little star. It's really a very nice variation on this pattern. In fact, it's quite beautiful. So here's another example from here, Seljuk example from here in Turkey. The 12-pointed stars, 8-pointed stars, 8-pointed stars. Because it's done as a border, the 8-pointed stars are disguised. You don't see them so readily, but they're there. Here's the double dart. Another early example, again from Anatolia. This one is also, the double darts have, in this case, they've been opened up. Instead of with a curve making a star, 6-pointed star, they've put two parallel lines. Two parallel lines. So here again, two parallel lines, right there and there, there and there, making this new motif. So again, the artist wanted to do something to give his own expression of artistic sensibility. And it's one of the things that Merrick and I were talking about this last night. It's one of the things that's so compelling about this artistic tradition of design, this design tradition, is that the geometry is allowed to resonate to the sensibilities of the individual instead of being fixed and rigid, and one thing makes one system makes one pattern, and that pattern never changes. It's much more full of playfulness and personal expression. Again, this is Karamanid. It's also here from Turkey. This is a late Abbasid example during the time when Baghdad was under the rule of the Seljuks, just before the Mongols came through. And this is a beautiful example of the same pattern. In fact, it's one of my favorites. You can see here that in this case, it's, the border has been cut out, but they've put the 12-pointed stars on the edges and the 8-pointed stars in the middle. So again, a little bit of difference. And now this is a Mamluk example of the same pattern that is done in inlaid stone, and it's very clear what's going on here. 12-pointed stars. Here's our double darts connecting. There's 5-pointed stars going around, 8-pointed stars on the edges. Look at this, see, it's beautifully composed. So the angle, the modularity of the square repeat unit is defining the angles for the corner. So you have the 8-pointed star precisely here and precisely here. That's a very good example because of the color, it's really easy to see it. This also is a Mamluk example. Again, it's very clear to see what's going on. The double darts, the 5-pointed stars. Every 8-pointed star is surrounded by a ring of 8 5-pointed stars. This is a Mamluk door, and because they've, now in this case, the artist has put the design into a border, and made the line of the cutting line so that it truncates the 12-pointed star in half and the 8-pointed star in half. So now you've got a single, two parallel lines of symmetry as the cutting points for the pattern. That's a close-up, and this is the full door to the mimbar. And another way of looking at this is they've taken these two panels and they've separated them and panelized them and put the stays for the door in between. But you can see that if you were to take this and put it against this, it would make a continuation. And that's quite beautiful because of the way the lines over, under, interweaving. Now, all of those previous examples were from the acute family, where the points of the star are more acute. They're more pointed. Now, this is the same underlying structure that I showed you that you'll see in a moment. This same structure, but using 2 points on every edge, it creates a different kind of pattern, but from the same underlying structure. And so this uses 2 points, so I call them 2-point patterns. I haven't learned the name in either Arabic or Farsi. I'm trying to find out what this kind of pattern is called in Iran. It shouldn't be too hard, but I've not been able to yet. But you can see nonetheless, once again, 12-pointed stars here, 12-pointed stars here, 12-pointed stars here, 12-pointed stars here. So that's the square module. That's the repeat unit, and the 8-pointed star precisely in the center. So you could say that this pattern and this pattern are like siblings, like a brother and sister. This is another 2-point pattern right here from a mimbar at the Kite Bay, and it's exactly the same pattern as the previous one. As I say, this was a very popular series of patterns made from this underlying structure. You find them all over. This is another Mamluk example in carved stone. It's from the Al-Azhar Mosque, which is very, very ancient, but this is from later Mamluk additions to the mosque. Now we're in Iran. This is an Ilkhanid example. Again, it's made into a border with the 8-pointed stars on the edges and the 12-pointed stars in the center. And in this case, these little interns, these little floral additions are the artist just wanting to do something fun and original. Maybe fun is not the right word, but something that gives an added new form of beauty. So now this is an example from Yezd. It's a Kartid example. The Kartids were not a long-lived dynasty, but they did some beautiful work. And this is actually a fresco. So this is painted onto stucco. It's a little bit hard to see because of the prominent foliation of these 12s into these floral elements makes you think that's the thing that's going on here. But beyond those, you can see here is an 8-pointed star. You've got 1, 2, 3, 4 stars around it. Here's this 8-pointed star with 1, 2, 3, 4 stars around it. And here are the double darts connecting the 12s. And these are, of course, the 12s. So it's kind of disguised because of those central prominent elements, but it's the same pattern. This is from the obtuse family, but it's the very same pattern. This is Timurid and 12-pointed stars with the 8 in the center. Very beautiful ceramic work they did during this period. And this is quite an exceptional example of an obtuse pattern. This is a median pattern where the angles, instead of being 36 degrees or close to 36, they're opened up to be more like around 70 degrees or 75 degrees. It depends upon what the artist wants to do. But I think there's a bit of a better example. Yeah, so this is the same. So now the double darts, the lines don't cross with each other. They don't continue across making the double dart. Instead, they open up. They breathe a little bit. It's more open. It has more breath to it. And so the corners don't match. Sometimes these elements will have a continuation and a continuation making a little rhombus in the center, but in this case the artist cut the lines where they intersect, making angles and making this a more open, an open structure. And similarly now, if you notice these 5-pointed stars, the angles are no longer so sharp, they're more open. So the controlling factor is this angle right here. There's a line going across like this, bisecting that angle. There's a line going like this in the underlying structure that you'll be seeing momentarily. And depending upon the angle of these crossing lines, if you imagine a line from here to here, depending upon the crossing of these two lines, the angle, whether it's more acute or more open, it determines the character of the finished product. So here again, 12s, 12s, sorry, that's an 8. 12, 12, 12, and 8, and 8. This is a beautiful piece from Afghanistan. Now this is from Spain, so here's such a breadth of distance. So all the way in Spain, again, around the same time as this pattern was being very widely used here in Anatolia and by the Mamluks. In Egypt, it was also being used in Spain, in this case at the synagogue in Toledo. So you have the 12s and the 8. Another example from the Alhambra, later than the previous, but the exact same pattern is in these window grills. It's interesting what the artist has done here. Look at this line, this parallel line in the pattern. So they've interrupted the pattern and arbitrarily put this parallel line in. Jean-Marc is really the person to speak to about this, but in the Western tradition of pattern making, the artists always strive, instead of putting the cut line through the line of symmetry, they will cut the pattern so you get a parallel line to the border. So you see this parallel line coming down and then going across here, then going back up, and they've even introduced it into the curve, which is unusual and very visually effective. And that's something in the Western tradition. When you, other than in Spain and in Morocco, Muslim artists did not strive to do this. They call it a river. Now, going from the extreme west to far to the east, is an example of the same pattern from Mughal India. And here again, instead of a continuation of the lines by widening it and having it go over and under, undulating, they've highlighted the individual cells of the pattern with a off-on or checkerboard, black-white contrast. In this case, the contrast is from a polished surface that reflects the light and a chiseled away rough surface that absorbs the light. So you get a strong contrast in the quality of light. And probably this was once painted. It looks like there are traces of paint, but I can't be certain of that. But again, 8-pointed stars, 12-pointed stars, 12-pointed stars, 12, 12 with 8 in the middle. And once again, the double darts. See the double darts right here? And around every 8 are 8 5-pointed stars. Exact same pattern. And now we're back to the mimbar that we will see tomorrow. And it really is a beautiful example of this pattern, so it warrants being shown twice. So now I want to go through a little bit what we're going to do in the way of our exercise. And so I just want to show you again, this is the acute pattern, the double darts, the 8 5-pointed stars, the 8-pointed star, and the 12-pointed star, the square module. It's all right there. You can see you could also modularize or create a repeat unit from the dual of that pattern and put the 8s on the corner and the 12s in the center. Either one works. But opening up those angles, if I just quickly show you, let's concentrate on this point right here. See these angles? They're approximately 45 degrees. And now they have opened up and they're around 80 degrees or 75 degrees, something like that. And so that change of angle opens it and changes the character of the design. You see what I was saying about how the design no longer carries through? These lines are carrying through at this point here. Now when you go to this more open, the lines no longer carry through, they change, and it creates an open area. If you carry it open even more, changing the crossing pattern lines so that they go from midpoint to midpoint to midpoint to midpoint to midpoint, you create a pentagon. And it's no longer a 5-pointed star, it's now a pentagon. This is the obtuse pattern. We're going to be making this one, but you can keep these, of course. The work that you do, you keep. And if you want to use the same underlying structure and experiment with these other patterns, that would be a good thing. This is perhaps the first one to start with because it's quite simple. You just connect straight lines from midpoint to midpoint and then extend them through into the two polygons, primary polygons. Am I speaking too fast? The translation was working? Good. And then the 2-point patterns take 2 points on each polygonal edge, and then you connect the 2 points from edge to edge. See how this is happening? It's really quite straightforward. And you create this really magnificent pattern that we saw examples of from Cairo. So those are the 4 pattern families. I'll just go through them again one by one really quickly. The acute family with the more acute edges. The more open or median, it's in between the obtuse and the acute, so I call it a median pattern. Again, I don't know the Persian name for this. By the way, in Iran, this family of pattern is actually called an acute family, or acute pattern. I don't know I've forgotten the name, the word for acute, but it's the term that's used. And this family is called an obtuse family, but I've forgotten that. I have to go to my sources and get that again. Now again, the 2-point. Now, so here's the pattern that we're going to work to make today. And this is from the mosque that we'll be going to tomorrow. And so I'm asking you to look at it and kind of get a sense of it and get to know it a little bit. And I'll just restate what I've been saying. So the 12-pointed stars are prominent. The 8-pointed stars are prominent. The 8-pointed stars have 8 5-pointed stars surrounding them. And the 12-pointed stars are connected by these double darts. Those are really the main characteristics of this pattern. So I want to, before I hand out the sheets, I just want to go through what you're going to be doing. This is not what you're going to be doing. I'm going to start you off with by providing you with already made radii matrices, or the radii matrix, because there's only so much time, and this is actually rather simple to make. I think that you're all going to be able to do it. I'm starting off by giving you the radii matrix rather than asking you to create it so that we can get more accomplished. But I just want to go through with how one can make the radii matrix so that if you want to experiment with making other kinds of designs using the same methodology, you can have an idea of how to do it. So in this case, I'm starting with a line. I've put it at 45 degrees, but you don't need to. I've drawn 2 circles, one centered at one end of the line, one centered at the other end of the line. The line could be this long, it could be this long, it doesn't matter. I don't need to give dimensions, it just needs to be a line. So now I'm drawing 2 circles. I'm taking each of the 2 circles and I'm dividing it into 24 equal parts. There are different strategies for dividing circles into even numbers of divisions. There are complex formula for doing this, very precise geometric formulae, but for artists and craftspeople, it's very easy just to use a compass or a pair of dividers and to calculate what it ought to be, to go around 24 times, and if you're a little bit, when you're a little bit short or a little bit long, you just modify your compass point a little bit in or a little bit out, depending upon if it's long or short. Do it again, and after 2 or 3 times, you'll hit it spot on. So it's actually not so difficult to do just by trial and, trial and error. So then I've got my 2 sets of, actually I'm sorry, this is 24 and this is 16. So 24 on one side and 16 on the other. So then I've drawn my radii. It helps to differentiate between the 2 types of radii. So there's 8 of one and 8 of the other, and I'm sorry, 8 of one and 8 of the other, and 12 of one and 12 of the other. So then what I've done here is I've then taken these points, 1, 2, 3, 4, made a little square, and that's going to be my, my repeat unit. Then I trim up the radii, and I end up with this, and then I rotate this form and get this matrix, and it's this radii matrix. It's not a difficult process, and it can be done with any number of combinations of radii, 12s and 9s, and you know, really there's a lot of areas you can play. Okay, so this is what we're going to be doing very shortly. You're going to start, I'm going to hand out the sheets that have these radii matrices on them, and the first step is to draw a circle that is tangent to all 3 edges of the radii, all 3 radii edges. So you start at this middle point, and you draw a circle that is tangent to those 3 lines. And the next step that you're going to do is you're going to draw lines that are perpendicular to these center radii and bisect these intersections of the circle and the radii. And it's a straightforward process. And at this stage, instead of being absolutely precise, you can eyeball it. It's all right to do that. You know, if you were in your computer and doing this, you can do it very precisely, very easily. And you could do it with a straight edge and a compass as well. But right now, I'm going to ask you to just do it carefully by eye, because that will be sufficient for the exercise. So then once that is done, you take circles from these 2 points, and you draw a circle from the outside of the 2 lines, like this and this. And then you draw lines that connect the intersections of the circle and the radii, making a dodecagon and an octagon. And now you can already see what's going on. You're establishing pentagons. If you do the same exercise in all 4 corners, you're really done at this point, because you can see there's a barrel hexagon here, and there are these pentagons. So anyway, coming back to this, now this is, what's the difference between those 2? Not a lot. They're the same, yeah. So now from this one here, I've darkened the lines of the implied pentagons and implied hexagons, or barrel hexagons, and I've emphasized them, and here I'm just showing it with no radii. So that's what we're going to do in the first exercise, and then the next exercise is to take these sheets, the ones that have the underlying grid, and I've given you center points to make it easy. And then you're going to go through the process of laying in the pattern lines. Okay, so it's a sort of a step-by-step procedure, and I'm going to keep these on the board, so when we're doing this, you'll have a visual reference. So then we establish points here, rotate them around 12 times. We do this 4 times in all. Now we're getting close to being complete. And we do the same thing, not the same thing, I'm sorry. We then take lines and continue from point to point, continue them across, then erase from the center, and you open these up. Then we take some points here, we're making our darts like that, and then clean it up a little bit. And the last thing are these areas in here, and we just introduce new lines in here and end up with a finished design. And then the last thing I would like to do today is to expand the pattern to give it some breadth. So starting with a pure pattern, I'm giving you this as a sheet. If we then, a simple process of drawing little circles, it doesn't matter what size the circles are so long as they're all the same size. If you want a narrow band, use a small circle. If you want a larger interweaving band, go with a little bit larger circle, but approximately this size is good. Then you just draw lines that are tangent to the circles, that are parallel to the lines themselves. Clean it up, or extend the lines to be corner to corner, clean it up, and either give it an interweave or not an interweave, depending upon what your sensibilities are. So I'm going to go back to here and hand out these groups of sheets. Good. Good, good, good. When you've drawn the circle, and some of you are drawing more than one circle, and that's fine. If you draw this circle and you do another circle in these additional points, you can do 8. That's absolutely fine. Or you can just do 1 and then draw big circles 4 times and 1 large circle here, and you'll establish the same thing actually more easily. But if you draw this circle first and then follow that by drawing these perpendicular lines, when I say perpendicular, it means that they are right angles to these 2 radii. This radii and this radii, they're right angles. Do you have a set? You do? Yeah. Here. Yeah. So if you've drawn your circle, the next thing is to draw these 2 perpendicular lines. And I'll show you, after you've drawn those 2 perpendicular lines. No, you really only need to do 1 circle. Yeah, it's really only, it's faster, how to say, additional circles are superfluous. But if you draw your 1 circle and then draw your 2 perpendicular lines. Yes? Yeah, sorry. So, yes, you've drawn the circle. So now you want to draw lines that intersect the circle and the radius. Here's the radius. Here's the circle. So there's an intersection right there. Now you want to draw a line that's perpendicular to it. And we don't need to be completely precise. Yes, perpendicular to the dotted radius lines, exactly. The next, after you've drawn the perpendicular lines, like this and this, you then want to draw 2 large circles, one that connects to the ends of this perpendicular line, and one smaller one that connects to this interior perpendicular line. Do you see what I've done here? We've established the perpendicular lines here, and we're taking those perpendicular lines and we're drawing 2 circles that intersect with the end points. Is that clear? And when you've got the circles drawn and you've got the dodecagon and the octagon drawn, some of you are ready to move to the next stage, and that is to copy decagons into the other 4 locations. And the way that that is done, dodecagons, the way to do that is to take the same circle as you used here, have your compass set at the same radius, and to draw it on these all four of the corners of the repeat unit. So you want to draw the same circle you drew here, 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 and here, so that you can then place. You can see it's a faint line, but there's a circle here and a dodecagon inside of it, a circle here with a dodecagon inside of it, a circle here with a dodecagon inside it. So you're going to be drawing 4 dodecagons. So some of you are ready to really complete the exercise. So, excuse me, I must have been tired when I did this, because this is the same as that. So look at either one of them, but you're going to end up, if you draw with your pencils in a heavy line, you can make the primary polygons, the dodecagons in the corners, and the octagon in the center. You can do those like I've drawn them here in a dark line, and then you follow that up with darkening the pentagons all the way around, all 8 pentagons, and the 4 barrel hexagons on the edges. And then you've finished it. And I want to emphasize, you've never done this before, and you're doing it really well, and it's not very difficult. So, and this is really the key to making this pattern. And this is a beautiful pattern, but there are a lot of other patterns that are equally beautiful, made from other radii matrices, and it's really within your grasp to do this. That's what I'm wanting to emphasize here, that these beautiful patterns, and even the complex patterns that have local regions of diverse symmetries, even these complex patterns are within the grasp of anybody who wants to apply themselves to the work. It's not beyond capability of any intelligent person. So I would like to move to the next exercise, because all of you are far enough along, even if you haven't finished this, to know what you need to do to finish it. So it's okay to leave it unfinished, because you've all done it enough to know what's needed. Some of you have finished. Even if you haven't finished, it's quite all right, because you can come back to finish it later, because you know what the objective is. So what I want to do now is to start the exercise for laying in the pattern lines, for placing the pattern lines into this tessellation. So if we go to sheet number 2, is it clearly marked? No. Yes, it is, worksheet 2. So worksheet 2 looks like this. Yeah, it looks like this. If we could go to worksheet 2, please. And you will notice that you've got this polygonal matrix, this polygonal tessellation, just like we were drawing in the previous exercise. And I've added little tiny circles at the midpoints of the polygons. And so these are the key points that our pattern lines are going to bisect. And so this is to make it easy. But if you're making these on your own, if you're making these, you can easily calculate the center points. I don't need to tell you how to do that. It's a simple enough process. Also, just to let you know that as these patterns become increasingly complicated, one doesn't pedantically stay at the exact center point. Sometimes what is important is the end result. And if the end result will be improved by moving the pattern line, moving the midpoint division a little bit one way or another, then that's perfectly acceptable. Sometimes they even move off of the line, but these are for the much more complex patterns. This is not a very complex, this is a modestly complex pattern, and the midpoints work just fine. So for the purposes of learning, this is a good one to learn from. So the first thing we want to do is draw an 8-pointed star, like this. And the way to do that is to draw 4 sets of parallel lines. So we're going to be drawing 8 lines through the octagon. And you can see if you start at one point, you're going to skip 1, 2, 3. You're going to go to the 3rd division, 1, 2, 3. And you're going to draw a line and extend the line a little bit in each direction, not just inside. Just to make it easier, you're establishing, essentially you're establishing the points of the 5-pointed star that's going to go inside each pentagon. So extend the lines a little bit beyond. It doesn't matter, it's arbitrary right now, it doesn't matter, it doesn't have to be a precise amount. We'll clean it up later. But for the purposes of right now, we want to draw an 8-pointed star by drawing 4 sets of parallel lines, and each line will be between 3 points of the sides of the midpoints of the octagon. So that's 1, 2, 3. See what I'm doing? And if you're starting here, it's 1, 2, 3. So you go from here to here. look at the, in fact, why don't you start on the vertical lines? It's a nice way to start. Start on the vertical lines. If you start here, right, at this point here, and draw a straight line down, vertical, that bisects that point, then you're good to go. Okay. Now the next thing is, if you want, you can erase the insides of the star to open up this star. You can erase the inside lines to open up the star. You can do that now or do that later, but eventually you're going to want, at some point you're going to want to clean up the star on the inside by just erasing the unwanted lines in the center. But that's a secondary thing, that's a cleanup process, that's not primary. But the next main event is to put our first lines for our 12-pointed stars. And draw these faintly, because you're going to want to erase most of it, okay? So just do this kind of faintly. But draw a line from the midpoint on the edge of the square, the midpoint of the dodecagon, right here. Can you find that line? You want to draw a line that bisects or runs through that line, and look where it connects to. It's not connecting up here to the midpoint of the dodecagon, but to the vertice. This is a tricky thing that you want to pay attention to. So the line is extending from the midpoint on the edge to this vertice right here. And rather than verbally trying to describe which vertice this is, it's better for you to just really look and concentrate on which one it is. The next thing is to draw a circle that bisects the lines. There's several ways you could do this next process, but we want to erase most of the lines here. If we draw a circle that bisects the line you've drawn with the first radius that it crosses on each side, you're going to end up with a figure like this. You see what's happened? Oops, sorry. See what's happened? We've gone from this. We want to trim it. We want to draw a circle that goes around, because that's going to give us points. You need, I should have said, the next step, forgive me, there's another step here I've forgotten to mention. We need to draw these lines of radius through the dodecagon, simply from midpoint to midpoint. So it's 6 lines drawn through the dodecagons. That's actually kind of a crucial thing I should have mentioned. So please do that. Please draw these 6 lines. Mm-hmm. So once you've gone 8 times around with this, in this exercise, once you've done this 8 times around, then you can erase the lines here and make nice little corners, because this is now, you can see you're starting to make 5-pointed stars in each of the pentagons. The 5-pointed stars are now really close to being completed. So if you erase these little points, see the difference between this and the difference between that and the difference between this is I've erased these lines, just the center points of the lines you've drawn. The 8 lines you've drawn, we want to remove the center parts. And instead of erasing, you can just draw the area that you want, darker if you want. If you did a light line, if you did a very faint line, instead of erasing it, you can just emphasize the lines by drawing in ink or with a pencil more heavily. But in any event, you want to be starting to look like this. And as you'll notice, you have a little ring of shield shapes, kind of shield shapes that you're getting in here. 8 shield shapes. And if you finish that, or you can come back to trimming, you can trim later, you can clean up later. But the next thing we want to do is the lines at the edges of the square repeat unit. And these ones, you're really almost completing the pattern now. These ones are going to connect, and they're going to run through. Remember how we ran through? These lines run through. They're not just from point to point, but they are a little bit extra long. Similarly, we're going to go now with the barrel hexagon on the center of each edge of the repeat unit, we're going to draw a cross, two crossing lines that go from the midpoint up here. Can everybody see that? From the midpoint here to the midpoint right here. And you're going to run a little bit long, and you're going to put two lines that go through. We're making our touching darts. This is the part of the pattern that makes the touching darts. So these lines go from the midpoint to the midpoint, but make them a little bit long, like that, on each of the edges. You're almost complete. The last step at this point is to put this little line here, putting these lines in here to make the dart. And they're a little bit, this last group of lines, one second please. So this last group of lines, you want this, the line that you've just drawn, this line here, this cross on the midpoint of the repeat unit, that angle, you want to repeat that angle with this short little line making the dart shape right here. And on the computer, it's really simple. You just mirror. But if you're not, if you're doing it by hand, it's not as straightforward. So I would just ask you to eyeball it. But you basically want to take this line right here that you've just done and reflect it on a very short length, reflect it to make this line right here. And that finishes your 5-pointed stars. So this is the very last point, the very last part of the exercise is to make this. If you've got it working, if you've made a line and you like it, you can establish the placement of it by making a circle and putting the circle 4 times and making that be your reference point. It helps, but, but really, for now, because time is of the essence, you're just wanting to make a little connecting line that is roughly the same angle, the reverse of this angle, a mirror of this angle on this side right here, making a nice, which makes this shape have bilateral symmetry. So it makes it very pleasing to the eye. So that's really the last step, and it's too much to complete these now because I have to conclude, but there's not time to do this final exercise, unfortunately, but I'll just explain it to you because you have the worksheets. Really, it's a simple matter to widen the lines. Of course, and if you have AutoCAD or some other software, you can just do this automatically. But to do it by hand, it's really a nice, easy process. You just put circles on every single vertice, and then you draw parallel lines, parallel to the pattern lines that are tangent to tangent on all of the different circles. You end up with a structure that looks sort of like this. And then it's a simple question of just cleaning it up, making it nice, even corners. Everywhere there's a nice, even corner. And then the inside lines you just erase or trace over is really helpful. Having tracing paper with making patterns is extremely helpful. Once you've ended up with this, then you just put a piece of tracing paper over it and you trace the areas and you get this or this, depending upon whether you want it to be an open pattern or an interweaving pattern. So just going back to this then, for the final step, to emphasize once again, there's not time to complete, I'm sorry. But you want to mirror this line. The axis is the radius. The radius. And this line right here, Carol, that's a radius line. That edge of the pentagon is a radius of the dodecagon. So you want to mirror on that line of the line between the barrel hex and the pentagon. If you use that as a mirror line and you make this little line, you'll finish your stars and your kites, or not kites, but darts, excuse me. So I'm going to speak to people here at the Istanbul Design Center and about having the worksheets available for either for download or for copying as PDF files. So thank you very much. And I'm so, and if I can just say, I haven't done very many workshops with this kind of complexity because the modular systems that you were working with yesterday with Peter, they're so immediate and they're so sort of friendly, and you can play with them and you can do new ideas and you can develop new ideas really immediately and fast, and it's efficient and beautiful. But this is more, it's not as immediate, and it takes more focus and concentration to go from through the whole process. So I've only done this kind of thing a couple of times with groups of people because it is more methodical, and you all did really, really well. And so I want to congratulate you. And lastly, I'd just like to say that I would encourage you to continue with this kind of work because, as I said the day before yesterday, there are an unlimited number of undiscovered patterns out there waiting to be discovered by people. It's not like the artists of the past completely finished. It's like think of portrait painters in the people who paint portraits. They'll never run out of material because there's an infinite number of people. Well, not literally, but there are way too many people to paint than you could never run. You can never run out of subjects because there's so many people to paint. And it's the same with the patterns. There's an infinite number of patterns to discover. So this method of making patterns can be applied to all kinds of new patterns that have never been made before. So I'll just conclude by thanking you and encouraging you to continue if you enjoy yourself. So thank you very much.